Okay, welcome back everybody. Day one of e-learning went okay. So yesterday we talked about graphing systems of equations and finding a solution. We're going to today do something very similar. We're going to talk about solving systems of inequalities. So we'll still only do this by graphing, but this time we've kind of got to add in our extra stuff for inequalities rather than for equations. It'll be just slightly different. Okay, so kind of staying with the same first step that we talked about yesterday, to decide if something is a solution to a system of inequalities, we're going to do the same process we did yesterday. We're going to take our point, remember this is an x value and a y value, plug it into each of our two inequalities, and see if it works for both. The only difference here is it's not equals. We're talking about greater than or less than. Okay, so our first equation there is y is greater than 3x plus 7. So we'll plug in our values. So 0 gets substituted in for y is greater than 3 times, for x we're going to substitute in negative 4 plus 7. So that would be 0 is greater than 3 times negative 4 is negative 12, and negative 12 plus 7 would give us negative 5. So we get to this statement here, so 0 is greater than negative 5. That's a true statement. So that means that that point works for that first inequality. So there's our first one. Since it works for the first one, we want to check to see if it works in the second. So now I'll take the other inequality. So I'm going to do 2 times y, which is 0, minus x, which is negative 4, is less than or equal to 6. Okay, so the 2 times 0, that's just 0, minus negative 4, that turns into plus a 4, less than or equal to 6. That would make 4 is less than or equal to 6. Also, again, a true statement. That means that the point works in both of those inequalities. So that means that yes, this ordered pair is a solution to that system of inequalities. Same thing for the other 2 points. So we'll go through the same process. If you want to kind of pause and try them out on your own, pause the video here, try B and C on your own, and then come back and check your answers. Okay, so for B, I'm going to plug in 4 for y, and I'm going to plug in negative 3 for x. That'll give us 4 is greater than, that's a negative 9 plus 7, so that'd be negative 2. 4 is definitely greater than negative 2. That one is a true statement, so I'm going to check the second one. 2 times y, which is 4, minus our x, which is negative 3, less than or equal to 6. That would be 8 plus 3. 11 is less than or equal to 6. Now, 11 is definitely bigger than 6. It is not less than or equal to 6. So that would mean that no, this ordered pair is not a solution to that system of inequalities. It doesn't work for both inequalities, so it's not a solution. And our last one, same thing, x and y. So 10 is greater than 3 times 1 plus 7. So 10 is greater than 10. Okay, now this one's a little bit tricky. This says that 10 is greater than 10. 10 is not greater than 10. 10 is equal to 10, but it's not greater than. So that is not a working inequality. If by chance this was a greater than or equal to, then it would work. But because it's just greater than, that is not a working inequality. And since that point does not work in that inequality, that means that no, this ordered pair is not a solution to the inequality or the system of inequalities. Okay, so same way we check with equations, we're just looking at greater than or less than rather than just equals. Okay, so how is the solution of a system of inequalities different than a solution to a system of equations? Well, when we looked at a system of equations, remember we were looking at where two lines cross, and that point in the middle is the one solution to our system of equations, right? Well, when we look at inequalities, remember when we graph an inequality, we graph our two lines, But now it's not just going to be that point where they intersect. There's also shading with inequalities, right? So we're going to look for where the shading overlaps. So it's not going to be just that one point that is our solution. It's going to be any of the points inside that shaded area or a shaded area. So this inequality will actually have more than one solution. It's going to be a range of solutions. Okay, we'll have lots of different ordered pairs that will actually work because of the shading. Okay, so we look at an example here. To solve our system of inequalities, we will only do this, or the inequalities, graphically. So same idea, graph each inequality, and then we're going to look for an overlap or where they cross. Okay, so our first one, and again, inequalities, it's even more useful if you're using a couple different colors. It's nice to have three, but if you only have two different colors, even if it's a pencil and then a blue pen or something, but something where you can tell the difference, it helps quite a bit. Okay, so I'm going to graph my first inequality here. Oops. Okay, so this first one, and we'll graph the same way. Remember, here's your y-intercept, and here's your slope. So I'm going to start up at +4 here, and we've got a slope of -2. So down 2, right 1, and so on. Again, just like when we did our systems of inequalities, it's important to fill up the entire coordinate plane. So if I go down and right, I can also go up 2 and left 1. Okay, and then if you remember with inequalities, we've got 2 extra things to do when we graph inequalities. We've got to decide, is it a solid or a dotted line? And then we also have to shade on each line. So those are the 2 extra things. So before you draw your line, we got to decide, is it solid or dotted? And remember, you decide that by looking at your sign there. That is a less than sign. It is only less than. It's not less than or equal to. So since it doesn't actually equal that line, we don't want to include the line. So this would be a dotted line. Okay, there's our first one. And then we got a shade, right? So if y is less than our line, that means, remember, when we talk about lines on a coordinate plane, we're going to look at up or down. So if it's less than, we're going to shade below the line. If it's greater than, we're going to shade above the line. Don't think right or left. Think up or down, or above or below. And you could always remember, start at your y-intercept. So I can start there. And then if this is less than, I want to shade below the line. So I'm going to go down the y-intercept. So that means I want to shade below the line, and I'm going to shade this first time very lightly. Don't shade really dark yet, or if you want to do like I did, just kind of make lines going in one direction. You don't want to shade it really dark because we're not totally done with this system yet. Okay, so then our second inequality, right here, this guy, again, we've got a y-intercept of 4, but a slope this time of +2. So y-intercept's in the same place, but this time I'm going to go up 2 and right 1, or I can go down 2 and left 1. So this line goes this direction. And this time we've got less than or equal to. So since we have that or equal to, this will be a solid line. Okay, and then our shading, again, we've got a less than sign. So start at your y-intercept and you want to go down from there, right? Now this one, remember, you're going to ignore the green line. So pretend like the green line is not there at all. And I want to shade everything that is below the purple line. So everything on this side. And again, you want to shade lightly, but you want to only think about that purple line. Okay, so now to find the solution for our inequality, our solution for an inequality is where our shading overlaps. So if I look at my purple and my green, well, up in the top right, I've got purple only. Top left, I've got green only. In the very top, it's empty, there's no shading. And then in this triangle down below, I have both green and purple shading. So that's where I'm now going to go back and shade in this part darker. That piece right there, that's where our shading overlaps. That's where our solutions to our inequality are. Okay, so this next piece here, if I want to name 3 points that are solutions to this system, as long as I pick a point that is inside that pink shading, then I've got a point that's a solution. So I could pick 0, 0. That's right there. That is inside the pink shading, so that is a solution. I could also pick something that's way off the graph. I could pick 1, negative 25, right? 1, negative 25. I would go to 1 and down, so it's way down here somewhere, right? But it would still be inside that pink shading. One other place that you can pick a solution is you can go on one of the lines. But if you're going to go on a line, it has to be on a solid line. So I could pick the point negative 2, 0. That's on my purple line. That's a solid line. So negative 2, 0 is a solution. Okay. All right, let's name some points that are not solutions. So again, anything that's not in the pink shaded area would not be a solution. So I could pick something like 5, 5, right? That is, see, 1, 2, 3, 4, 5. That's up here, right? That is not in the pink shaded area, so that is not a solution. I could pick 0, 20. That's way up top up here, right? That would not be a solution. Another way is you can pick one that's on a line, but if you pick one on a dotted line, it's a not solution. So if I pick the point positive 2, 0, that's over here on my green line. That is a dotted line, so that's not a solution. Solutions on lines are only solutions if they're on a solid. If they're on a dotted line, it's not a solution. Okay, so there's our graphing a system of inequalities. Graph each line, think about solid or dotted, shade each one, and then look for where their shading overlaps. And then we can name points that are solutions or not. Okay, let's try a few more here. Okay, so this one, we want to graph each one separately. Well, before I graph these two, these are not in slope-intercept form, right? It's always easier to graph a line if we've got it in y equals mx plus b. So I'm going to take each one and solve each one for y. So the first one, 3x plus y less than or equal to 4. I've got to subtract the 3x over. So that'll give us y is less than or equal to negative 3x plus 4. There's our first one. So y-intercept up at positive 4. And then our slope is negative 3 over 1. So down 3 to the right 1. And fill up your whole graph. Down 3 and right 1. Or I can also go up 3 and left 1. Before I draw my line, I'm going to look at my inequality symbol. It's less than or equal to. That means I want a solid line. Yeah, that's kind of crooked. There we go. And if it's less than or equal to, that means I want to shade below the line. So y-intercept go down. I'm going to shade this side. Okay. Okay. And the next line, again, I'm going to take it and solve for y first. So this one is 3x plus y greater than or equal to negative 1. We'll subtract our 3x on both sides. We get y is greater than or equal to negative 3x minus 1. Okay, so y-intercept is negative 1. Slope is negative 3. So down 3, right 1. Down 3, right 1. Or I can go up 3, left 1. Up 3, left 1. And again, we've got a greater than or equal to sign. So I want to use a solid line. Okay, now notice these two lines, they have the same slope, right? Negative 3 and negative 3, which means we've got parallel lines. Now, before when we did systems of equations, if we end up with parallel lines, we said that was no solution because those lines never intersect, right? But now we're talking about inequalities. So we don't have to have the lines intersect. We just need to see where the shading intersects. So if there's shading that overlaps, then we still have a solution here, even though the lines are parallel. Okay, so this one, our purple line, said that y is greater than or equal to. So that means I want to go to the y-intercept and I want to shade above the line. So I would be going this direction. Okay, so then if I look at my graph, the spot where the shading overlaps is actually right in between these two lines. So that's where our solutions are. Okay, so then on our two lines here, if we want to name a point that is a solution, I just have to pick a point that is inside of that pink shading. I'm going to go with +1, -1. So 1, -1. That would be the point right there. So it's definitely inside the pink shading. A point that's not a solution, I could pick 5, 0. That is way over here, definitely not in the pink, so it's not a solution to the system of inequalities. Okay, so just keep a lookout. You can still have a solution to a system of inequalities even if the lines are parallel, as long as the shading overlaps. Now, it is possible to graph parallel lines and then the shading doesn't overlap. So if you have a situation where your shading doesn't overlap, then there won't be a solution to that system. All right, let's try one more here. This time we've got 3 inequalities, right? So it's also possible to solve a system of inequalities if you have 3 different equations. And do it the same way. We're going to just graph each one. So our first one here, x plus y is less than or equal to 6. Again, I want to solve that for y. I'm going to subtract x on both sides. So y is less than or equal to -x plus 6. We've got a y-intercept, 1, 2, 3, 4, 5, 6, right there. And a slope of -1, so down 1, right 1, all the way across my graph. And also go up 1 and left 1, right? This is a less than or equal to, so we want a solid line for that one. Right. Okay, so there's our first one. And it said less than or equal to, right? So that means I want to shade below the line. I'm going to go this direction. And again, shade lightly for these first few, or if you're using different colors or however you're going to do it, that helps. Okay, next equation. I've got x is greater than or equal to 1. Now, if you remember from our graphing, there's no y there. So if x is always 1, means I can go to x where x is 1 and put a point, and that's going to make a vertical line. X equals is always vertical, right? That's a greater than or equal to, so I want a solid line. So that one is going to look like this guy. And if I want it to be greater than or equal to 1, now this is just x, so I can't go up or down, I got to go right or left. So greater than or equal to 1 would go to the right of that line. So going this way. Okay, so we can already see the spot where the green and purple overlap down there in the bottom right. We've got one more equation to graph. Y is greater than or equal to 0. Now that one doesn't have an x, so we go to where y equals 0 and put a point, and that is a horizontal line. That's going to be right on our axis, right? Looks like that. Another solid line because it's greater than or equal to. If it's greater than, I'm going to shade above that line, so I want to go this direction, right? So now we kind of have several different pieces of our graph there, but there is one spot right in the middle, right in this little triangle right here, where all 3, purple, green, and pink, all overlap. So that's where our solutions are, right? So a solution in that inequality, I could pick 2, 1. Okay, that point is right there. That is inside that blue shading. If I want to pick a point that's not a solution, basically anywhere except for inside that triangle or on any of the lines. So I could pick 0, 0, 4. Right, that is right there. That is not a solution because it's not inside the blue shading. Okay, so remember your horizontal vertical lines. That will help a bit. We got to remember our solid or dotted lines when we're doing inequalities, and then you got to remember where to shade when you're doing your inequalities. And try to use either different colors or just shade lightly, and then you got to go back and shade darker so I can tell where your solutions are when you're shading them in your inequalities. Okay, all right, today's homework assignment is also on Delta Math, so very similar to yesterday. You're going to go in there and complete those. There's some instructions on the homework page in OneNote, and I will remember to be available today during our class time. If you have any questions on yesterday's homework, please let me know.